Hello, welcome back. This is a video over Unit 6, Section 2, and we're going to be talking about zero and negative exponents today. Okay, so let's quickly come over here and talk about, we have three types of exponents. Okay, we have positive exponents, which we talked already about in Unit 6, Section 1 video. But today we're going to explore a zero exponent and a negative exponent. And some of the patterns that we see, from, what happens if you have a positive exponent, zero exponent, or negative exponent, okay? So let's take a look at the table here, okay? And so it says use powers of 4 in the table to evaluate powers that have zero and negative exponents. Now, what I want you to look at is that if I'm going in this direction, okay, if my exponents, as my exponents get big, okay, we are multiplying by 4, okay, by 4, all right? So here, to go from, this step to this step, okay, I'm really doing 4 times 4 to give me 16, okay? From going from this step to this step, I'm doing 16 times 4, which is going to give me 64, okay? So what I want to do, we know that pattern going in this direction, okay? However, if we go in this direction, what we notice is that exponents are getting smaller. Okay, they're decreasing. Okay, therefore we want to do the opposite of what we were just doing. So to go from one step to the next, we want to divide by 4. Okay, and that's what we're going to do from step to step. Okay, so to go from this step to this step, if I think about it, really I'm doing 64 divided by 4, which gives me 16, okay? To get from this step to this step, I'm doing 16 divided by 4 to give me 4, okay? Now here's the crazy part, okay? So we're going to venture into, we've got an exponent of 3, 2, 1. We're going to now explore what happens when I have 0, -1, and -2. So if I do this and go from this step to this step, really what I'm doing is I'm doing 4 divided by 4, which is going to give me a value of 1, okay? Now, to go from this step to this step, I'm taking my value that I got, which is 1. I'm going to divide it by 4, and that's just going to give me a value of 1/4, okay? And let's go the same way. And I'm going to do 1/4 divided by 4, okay? And when I do that, if I'm dividing by 4, and let's write this down here, dividing by 4 is the same as multiplying by the reciprocal 1/4. Multiplying by 1/4. Okay, so I'm going to rewrite this as 1/4 times 1/4. When we multiply fractions, we simply multiply across. 1 times 1 gives me 1. 4 times 4 gives me 16. Okay, and one pattern I want you to recognize here, from these two numbers is that if I go out here, 1 to the 4th, 1/4 is really the same thing as 1/4 to the first power, okay? Down here, I had 1/16. That's really the same thing as 1/4 squared, okay? And we're going to come back to that. But before we move on to that, I want to talk about this thing that we got for the zero exponent, okay? If we apply the same concept to all other problems, okay, what we're going to have happen is that if we raise anything raised to the 0 power is 1, okay? And we call this the zero exponent rule, all right? So, if we read this, the value of any base other than 0 to the 0 power is 1, okay? So the zero exponent rule, some number a raised to the 0 power is 1. And what I want to write here is any number raised to the 0 power equals 1, okay? So just make sure you write that in there. I know we are saying the exact same thing here, but I just want to put it in a little bit simpler terms. Okay, and we can think of examples here. All right, so an example, let's write out like 15 to the 0 power. That's going to be 1, okay? What if I had 300 to the 0 power? That's going to also give me a value of 1. What if I had like, 17/5 raised to the 0 power? It's going to also give me 1. What happens if I take negative 327, raise that whole thing to the 0 power? It's going to give me 1. Okay, so anything raised to the 0 power is going to give me 1. And in future videos, I'll talk more about, kind of how another way to look at this. All right, but that's the idea. Any number raised to the 0 power is 1. Now, negative exponents. Now, notice something that we got here. Here's our negative exponent rule. Some number a to the negative nth power is going to be equal to 1 over a to the nth. I want you to look at something. In the problem that we had 4 to the negative 1 power, okay? And we ended up getting, as a result, 1 over 4. And that's just raised to the first power, which really just gives us 1/4, okay? So I want, we already established this. We already kind of figured this out. Now, if I look at 4 to the negative 2 power, all right, that's going to be, using this rule, is going to be 1 over 4 squared, okay? And 1 over 4 squared is 1 over 4 times 4, which is going to give me 1 over 16, which is what we got. Okay, now let's extend this idea. Okay, let's do this again. All right, so if I've got 4 to the negative 3 power, all right, this is really just going to be, using my rule, is 1 over 4 cubed, all right, which is going to be 1 over 4 times 4 times 4, which gives me 1 over 64, okay? And so, think about it from here. Remember how we were just simply dividing by 4 or multiplying by 1/4? Same thing. All right. If I was trying to go from, this step here down to here, all right, remember what I would do? I would take 1/16 and I would multiply it by 1/4. And 16 times 4 is just 64, so 1 over 64. All right, so same idea. So, moral of the story is that if you have a negative exponent, what you want to do is do this. I'm going to put this over 1, because I can do that with any fraction, okay? I take my numerator, and I put it down into my numerator, and it becomes positive, all right? And then you can evaluate it, all right? And so I'll have more, we'll do more examples on, how this works and why this works, but that's the idea, okay? So, all you're doing is moving the negative exponent to the other side of the fraction to make it positive. Okay? And that's all we're doing. All right? So now let's come over here and let's talk about fractional bases and negative exponents. So a fraction raised to a negative power is equal to the reciprocal of the fraction raised to the positive power. So I want to show you guys how this works. Let's say that we use the same concept, thinking about it from, if I'm going to go put this over 1, and to go from this side of the equation to this side, all I'm doing is taking my exponent, or a to the negative n, and putting it under here and making it positive. Okay, so make positive. All right, so because of that, it also works the other way around. Okay, for example, let's say I had 1 over a to the negative n. Okay, if I wanted to turn this around, then all I would do is take this value, move it to the top, and that's going to give me a to the n over 1, okay? So because of that, you know, what I can do is this, all right? I can say, if you think about a fraction, okay, remember our rules about fractions is that we can take the numerator raised to the power and the denominator raised to that power. And so I have a to the negative n over b to the negative n. Now, all I'm going to do is I'm going to take my top part, move it down below, take my bottom part, move it up, and make them positive, all right? And so what that's going to then give me is it's going to give me b to the n over a to the n. Now, if I have a numerator and denominator both raised to the same power, then I can just take that fraction, b over a, and raise it to the nth power, okay? Now, another way that we can look at this, okay, is this, all right? Let's say I have 2/3, so here's an example, okay? Let's say I have 2/3 raised to the negative 2 power, okay? Using our rule of exponents, one thing I could do is I could take 1 over the entire fraction, 2/3 quantity squared, okay? And all I'm doing is I'm just applying this rule here to a fraction, okay? And so it's a quantity, all right? Now, what I can do is I can take 1 over, and I can do this as 2 squared over 3 squared, all right? Which is going to end up giving me the value of 1 over 4 ninths. Okay, now if I'm doing 1 divided by 4 ninths, all right, and I can look at it this way, 1 divided by 4 ninths, if I'm going to do this, do division by a fraction, it's the same thing as multiplying by the reciprocal. And so this is really going to become 1 times 9/4, which gives me 9/4. Now what I can do is I can rewrite 9 and 4 as something squared, and rewrite 9 as 3 squared over 2 squared, all right? And so then I can rewrite that as 3/2 squared, okay? And all of this is equal to that original thing that we had in the beginning, which is 2/3 raised to the negative 2 power, okay? And so all you're doing here is you're taking this fraction, okay, and you just flip it and make your exponent positive, okay? So kind of confusing, but, you know, you can look at this a number of ways. Okay, and we can extend this idea to something with a variable base, and we can simplify these expressions here. So if I had y to the negative 6, then all I'm going to do is apply my rule, all right? I'm going to put this over 1, and I'm going to take my number here and bring it down below and make it positive. And I'm just going to have 1 over y to the 6th power, and that's it, okay? That's all I'm doing to simplify that. Now, if I have p to the 0 power, anything raised to the 0 power is just 1, okay? So pretty simple there. Now, over here, we have u to the negative 12 minus r to the negative 5th power. So what I have here is if I have u to the negative 12, I'm going to rewrite that, put each of these over 1, okay? And to make them positive, I'm just going to move them down into my denominator. So I have 1 over u to the 12th minus 1 over r to the 5th, okay? And I would just leave it like that. There is some more simplifying you could do here, but we don't need to do that. Okay, now, what if we were simplifying a variable-based expression using multiplication? So notice what I'm doing here is I've got m to the 5th times n to the negative 2, all right? So let's rewrite this as m to the 5th times n to the negative 2 power, all right? Now, what I want to do is simplify this and rewrite using positive exponents. And so when I'm looking at this, the whole thing is being divided by 1. I can turn anything into a fraction, okay? Even if I'm multiplying two things together, I can still just put that over 1. Now, to turn this into a positive, I would take my n to the negative 2 and simply just bring it down below and make it positive, okay? And so my answer here would be m to the 5th over n squared. And I would just leave it like that, okay? Because my goal is to write with positive exponents, okay? We don't like to write with negative exponents, just not something we typically do. Okay, now this is a case where you had, you know, m to a positive number, n to a negative number. If you both had negative numbers, okay, and you can look at this two different ways, okay? I'm going to do this. I'm going to write j to the negative 6 times p to the negative 9. And I'm simply just going to put this over 1, okay? So if I have these, I'm going to take each of them and bring them down into my denominator, all right? So this is just going to give me 1 over j to the negative 6, I'm not to the negative 6, to the positive 6, times p to the 9th, and that's it. Okay, so then the other the other way that you can look at this is to separate this out and to think of j to the negative 6 over 1 times p to the negative 9th over 1. And all you're doing is you're going to take these and move them down below. Same thing we did before, except for instead of like dealing with one fraction, we're dealing with 2, which is no big deal. We're going to get the same thing in the end. But I'm going to do 1 over, okay, j to the 6th power times 1 over p to the 9th. Now, multiply across, 1 times 1 just gives me 1. J to the 6th times p to the 9th is simply just going to be j to the 6th times p to the 9th. And that's all you're doing, okay? So a lot of this stuff, you're just simplifying, okay? But remember, the goal is to write these expressions with positive exponents, okay? And that's the idea, all right? So you have to understand, you know, where these, you know, where it comes from. And we'll talk more about how you develop a negative exponent and a positive exponent in the next couple of videos. Thanks. See ya. Bye!